Welcome back to lesson 6. In this lesson we'll try to begin to see how to find resultant of a system of forces. In specific, in this lesson we'll be interested in coplanar forces which are concurrent. Okay. Coplanar concurrent forces. When we say coplanar, we mean that all the forces lie in a single plane, and when we say concurrent, we mean all the forces meet at a point. Okay, that is, we'll try to see how to add vectorially using parallelogram law. And for this lesson we'll try to focus on graphical method. Okay, so in this lesson we'll try to find how to add vectorially using parallelogram law graphically to find the resultant of coplanar concurrent forces. Let us try to begin with a simple example. Okay, suppose we are to find the resultant of two forces acting as shown here. One force is shown here, 300 newtons, and another force making an angle of 60 degrees and with a magnitude of 400 newtons. Because we are saying that we are solving the problem by using graphical method, we'll employ a convenient scale. For example, in this case we may take 1 centimeter is equal to 100 newtons. So this force, 300 newtons force, will be a 3 centimeter long line. This 400 newton force will be a 4 centimeter long force. So what we do is we'll actually try to use a scale pencil and protractor. We begin with a point O, from where we draw a line OA with a length of 3 centimeters. This line represents the 300 newton force, and then we draw another line making an angle of 60 degrees, okay, with OA, because the angle is 60 degrees. This OB is chosen to have a length of 4 centimeters, and then according to parallelogram law we need to complete the parallelogram. That is, from B draw a line parallel to OA, from A draw a line parallel to OB, so that they meet at the point C. Okay, our resultant now is OC. So what we mean is, instead of applying two forces OA and OB, we can just apply one force R. So this R will have the same effect as forces 300 newtons and 400 newtons put together. If you actually take a scale and using this rule, 1 centimeter is equal to 100 newtons, if you actually find out the length OC, this OC will be approximately 6.1 centimeters. Okay, this is what I got. When you actually try to draw it, you may get slightly different result, maybe 6.15 or 6.2 or something like that. Such deviations are expected. and also you need to measure what is this angle. Okay, this angle alpha comes out to be 34.7 degrees. Because we are using a scale of 1 centimeter is equal to 100 newtons, this 6.1 centimeters corresponds to 610 newtons. Okay, this is one example. Let us look at another example. Okay, find the resultant of these three forces. One force here, one force here, and one force here. The magnitude of this force, let us say, is 500 newtons. The magnitude of this force is 100 newtons, and the magnitude of this force is 300 newtons. Okay, the first thing we see is, because we have three forces, somehow or the other we need to reduce them to two forces meeting at a point. Then we can apply parallelogram law. Okay, to do that, we'll first split this 500 Newton force into two forces. One force which is 400 newtons, one force which is 100 newtons, and another force which is 400 newtons. So we have one force from here to here which is 100 newtons, another force from here to here which is 400 newtons. So 100 plus 400 is 500. So we have the same force, and then you have another force which is 100 newtons, and a third vertical force 300 newtons. Now you can see that the magnitude of this force and magnitude of this force is identical, 100 newtons. Both of them are collinear. Okay, and they are oppositely directed. Okay, oppositely directed, collinear, and same magnitude. So this 100 newtons and this 100 newtons, they are a system of forces in equilibrium. Okay, because these are forces in because these are the set of forces in equilibrium, you can subtract them according to principle of superposition. So if you subtract them, the situation would be like you have a 300 Newton force and a 400 Newton force. Okay, again, using principle of transmissibility, you can move this point of application here. When you do that, your system of forces is like this. Okay, once you realize this, you can again take a scale, a very convenient scale, which in this case also could be 1 centimeter is equal to 100 newtons. Okay, then starting with a point O, you draw a line OA, okay, of length 4 centimeters to represent the force 400 newtons, and then from here you can draw a line OB of length 3 centimeters and perpendicular, sorry I forgot to mention this, the force 300 newtons here is perpendicular to the set of forces. This angle is 90 degrees, and so this angle is 90 degrees, and hence this angle is 90 degrees. So you will draw a line OA of 4 centimeters long, OB of 3 centimeters long, and now complete the parallelogram. In this case, the parallelogram is a rectangle, and join this to find the resultant. Okay, if you actually take to scale and draw it, you will get this length OC to be 5 centimeters and the angle alpha to be 36.86 degrees. Okay, because our scale is 1 centimeter is equal to 100 newtons, you will have magnitude of R bar is 500 newtons. Okay, again we note that since this is the resultant of forces 300 newtons and 400 newtons, this resultant R, that is if you apply a force of 500 newtons making an angle of 36.86 degrees with OA, this force will have the same effect of both the forces F1 and F2 put together. That is, once you find the resultant, you will apply only resultant and you can remove these two forces, and still the system is the same. Whether you apply a single R here or you apply two forces of 400 and 300 newtons, the system is going to be the same. Effect on the system is going to be the same. With that, we end today's lecture. Thank you very much and have a good day.